So before you start telling yourself that scientific notation is one of those useless things you are never going to use again, let's understand what scientific notation is used for. Well, we say, for example, that human hair has a width of 0.00008 meters. And we say, for example, that a carbon atom has a diameter of 0.00000000034 meters. Now, if we had to write these numbers out over and over again, it would get really long, really painful, and we would easily make a mistake because there's so many zeros we would get confused and make a mistake. So that's one thing scientific notation is used for. It's used to write these numbers more easily. So we'd say, for example, 0.00008 would be equal to 8 times 10 to the power of negative 5. And this would be equal to 3.4 times 10 to the power of negative 10. Now, I'll show you how we get to that in the next video. But for the moment, just realize how it is so much easier to write it like this than it would to write it with all those zeros. So now, for example, let's look at the number of Enigma settings. Number of Enigma settings. And we say there are 159 quintillion of them. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 159 with 18 zeros behind it. So if we had to write that number over and over again, we would get confused, and there'd be a really big chance we'd add a zero somewhere or forget one. So that's another reason we use scientific notation, is to write really big numbers with lots of zeros. So here, for example, we say that 159 quintillion would be 1.59 times 10 to the power of 20, and that is so much easier to write. So if we sum it up, we say we use scientific notation to write small numbers with lots of zeros much more easily, and to write big numbers with lots of zeros much more easily.